The next problem says, find three numbers such that the first is the sum of the second and the third. The second is the square of the third, and the sum of all three is a maximum. So this isn't like the one before because there's no shapes involved, but it's still a good optimization problem. So first let's find the numbers. It gives you that the first is the sum of the second and the third, then the second is the square of the third, but it gives you nothing about the third. So that's why you can go ahead and make the third number equal to x. And if that equals x, then the second is a square of that, making it x squared. And the first is the sum of x squared and x, which is just x squared plus x. Now the sum of all of them together is going to be x squared plus x squared plus x. And like any optimization problem, after you have the equation, you're going to want to take the derivative. And the derivative of this is going to be 2x plus 1 plus 2x plus 1. And when you simplify that, you're going to get 4x plus 2. Now, since it's looking for a maximum, you're going to set this equal to 0 because a maximum is when the derivative equals 0. When you set that equal to 0, you're going to get x equals negative 1/2. So that's the third number, negative 1/2. The second number is just negative 1/2 squared, which is just going to give you a positive 1/4. And then the first number is a negative 1/2 squared plus 1/2, which is just 1/4 plus 1/2, which is going to be 1/4 plus 2/4. No, not 1/4 plus 2/4. It's going to be negative 1/2 squared plus negative 1/2, so plus a negative 2/4. And that's going to give you a negative 1/4. So the three numbers are negative 1/2, 1/4, and negative 1/4. Okay. Now the third problem says a rectangular box of height y has square base with sides x centimeters long. If the box is open at the top, determine the dimensions that have the minimum surface area. Find the minimum surface area if the volume of the box is 32 cubic centimeters. Now again, it's asking for a minimum, which is why it makes this an optimization problem. So first, draw a picture. It has an open top, dim x, height y. Now it gave you that the volume of the box is 32 cubic centimeters. So the volume of this is going to be x squared, x times y. That's going to equal 32. Now the surface area of this figure is going to be x squared plus 4xy. Now, the next step is going to be to solve for one of the variables. And now the easier way is going to be to solve for y. So divide by x squared, just because this is an x squared, and that's just going to make it more difficult. So y is 32 over x squared. Now once you have this, you're going to get surface area equals x squared plus 4x times the y, but the y equals 32 over x squared. You're going to solve this and get x squared plus 128x over x squared. You can cancel out these x's and get x squared plus 128 over x. That's what the surface area equals. Now, you're going to take the derivative of this and get SA prime equals 2x. Well, first, set it up in a way so that you can take the derivative. So SA equals x squared plus 128 times x to the negative 1. And now take the derivative which is going to be 2x minus 128x to the negative 2, or 2x minus 128 over x squared. Now, like I said, it's asking for a minimum. You're going to want to set this equal to 0 because, again, the minimum is where the derivative equals 0. So 2x minus 128 over x squared equals 0. 2x equals 128 over x squared. You cross multiply, you get 2x cubed equals 128. Divide by 2, divide by 2, you get x cubed equals 64. And therefore x equals 4. But it asks for the dimensions and the surface area. So dimensions are going to be 4 centimeters by 4 centimeters by y, let's solve for y, and get 32 over 4 squared, which is just 16, and it's going to be 2 centimeters. So these are the dimensions of the box. Now the total surface area, you're going to need to plug back into this equation. So let me get my piece of paper. If the surface area equals x squared plus 4xy, x is 4, plus 4 times 4, and y is 2. You're going to get 16 plus 4 times 4 times 2 is 32. And if you add this, you're going to get 48 centimeters squared, and that's the surface area. Surface area 48 centimeters squared, and the dimensions are 4 by 4 by 2.